Continuing on our journey talking about inheritance, this bit is going to be a bit about abstract classes and a few other concepts. I would say this is an important video to watch before taking Quiz 2. It's not especially closely tied to Lab 2 or Lab 3, but it is an important concept. It is possible to create a class strictly for inheritance, and this is called an abstract class. So the idea is maybe you have a class called person, and then you derive from it a student, a teacher, an employee, whatever. Earlier, we had one about instantiating objects, and we had a group of dogs. It could be that there's a dog class and then several subclasses that are breeds, and the breeds all have their own features. And you would never instantiate a dog without a breed, you would only instantiate the different breeds. So you could have constructors for the different breeds that would make these useful instances of dog. It is possible to make an abstract class without declaring it as abstract. You would just choose not to instantiate it. But you can also specify it by using the keyword must inherit. The methods that this class might have, if they have to be overridden, they have to have the keyword must override. So you could make kind of a placeholder for a method that every subclass would require using must override. As a bit more of a close-to-home example, here at Durham, we're all in this system called Banner, and we all have a Banner ID. So each of us, you might call it your student number, but it's that 1009-digit number. We're all associated with a Banner ID, and they have a name for each of us, they have an address for each of us, a birth date for each of us, and probably a lot of other things, maybe some of which we don't even know about. I've never been into the depths here, so I'm not sure. So these could be considered to be class properties of an abstract class called person. Now suppose there are subclasses of person. There's probably more than this, but let's just go with faculty and student for now. They're going to have all of those properties mentioned earlier, but they're also going to have some of their own. So they can both log into MyCampus and DC Connect. So maybe logging into those two services are methods. Only faculty can enter grades. Students can't do that. And only students have DC mail accounts. This is probably a good opportunity to remind you that you have a DC mail account. So these methods would be defined as a part of these subclasses. This is more of a computer science thing. We're not going to go into detail with this, but this is a class diagram. So here's an example where we've got a person body and then two subclasses, and there's student and there's faculty. And so person has several properties and methods, and then we've got a student and a faculty subclass that have the ability to log into DC mail or enter grades. We wouldn't instantiate just a person. There's no reason for us to do that, but we might do it for student and faculty, and so it's a bit of an efficiency having those properties on the person. If you like this kind of diagram, if this kind of thing helps you to understand inheritance, I'd recommend a quick Google search for class diagrams. You can see some pretty neat ones just in the first several results. To go back to accessibility, and we've already touched on this when I was going through the payroll class, but you need to be aware of this for your lab, and most people did a pretty good job with this. With exercise 2, it seemed like a lot of people were using the friend access specifier, which is correct. You could use protected friend, but you certainly didn't have to. But as we start working with inheritance, you're going to make more use of the protected access specifier, which make things accessible from inside the class, or a class inheriting from this class, which does include child classes. So you will be making use of that.